Hello, you are most welcome. I'm teacher Ivan from Wuna Educational Services. I welcome you to our second chapter of A-Level Physics 1. In this chapter, we shall be looking at linear motion, which is motion in a straight line. The terms used under this are distance, which means length between two fixed points, displacement, which is the distance covered in a specific direction. We have speed, which is the rate of change of distance. We have velocity, which is the rate of change of displacement. We have uniform velocity, which is the constant rate of change of displacement. We have acceleration, which is the rate of change of velocity, and lastly, uniform acceleration, which is the constant rate of change of velocity. After looking at the terms used, we continue and look at the equations of a uniformly accelerated motion. But before we derive the equations, we should know what is meant by a uniformly accelerated motion. This is simply the type of motion in which the velocity of a body changes by equal magnitude in equal time interval. Or we can also define it as the kind of motion in which there is constant rate of change of velocity. When it comes to deriving, there are three equations that are used under uniformly accelerated motion, and these ones are derived using acceleration, final and initial velocity, time taken, and total displacement. Now, we shall consider a body moving in a straight line with the uniform acceleration of a meters per second squared, and this increases its velocity from u meters per second to v meters per second in a time t seconds. Then that means that acceleration of this body will be given by the change in the velocity, that is final minus initial, over the time taken. So from this formula for acceleration, we shall make final velocity the subject, because it's what we don't know. So in making v the subject, we shall first of all multiply by time, and this gets us at equaling to v minus u. And then we take u to the other side, which gives us 80 plus u equaling to v. And therefore, we get v equaling to u plus 80. So, this is the first equation of a uniformly accelerated motion. Then the second motion, we shall still consider an object with the initial velocity u meters per second, moving with a uniform acceleration a meters per second squared for a time t in seconds, and attains a new velocity v meters per second. The distance traveled by the body will be given by S in meters. So it is the distance covered by this body that we are looking for in this case. Now, given the details, that distance covered will be the average velocity times time taken. That's how we shall get the distance covered. But average velocity is given by the initial plus final over 2, since it is average, times time t. However, V is already gotten as U plus AT. So we substitute for V, because at that time we may not know the final velocity V. And therefore, the distance covered in that particular direction will be U plus AT, this over 2 times T, which gives us, if we are to simplify, we shall add the U, so that we get S equaling to 2U plus AT over 2 times T. And therefore, this gives us, when we open bracket, we shall have S equaling to 2UT plus 8 squared over 2. When we separate the fraction, we end up with the 2UT over 2 plus 8 squared over 2. And therefore, this gives us UT plus a half 8 squared. And this will be our second equation. Then from there we come to the last and the third equation. For the third equation, we shall also use the same technique, whereby we saw that the total distance covered will be the average, which is U plus V over 2 times the time taken T. But this time round, we are substituting for time. So we shall say that, but from V equals to U plus AT, then we make it the subject. Hence, we shall have V minus U over A equaling to T. So we are now, instead of writing T, we shall replace it with this. And therefore, the total displacement equals to U plus V over 2 times V minus U over A. And now, this gives us S as V plus U plus V, and then V minus U over 2A. But if you look at this, this is a difference of 2 squares, and therefore we shall have S as V squared minus U squared, because it is V minus U. This one doesn't matter, but what matters is the one with the minus. So it is V squared minus U squared over 2A. Then we cross multiply and make V the subject. And therefore, that gives us 2AS equaling to V squared minus U squared. When we take U the other side, we end up with the 2AS equaling to, 2AS plus U squared equaling to V squared. And therefore, that gives us v squared equaling to u squared plus 2as. And this is the third equation. So, with that, I beg to pause from here. And in our next lesson, please don't miss out on our next lesson, because we shall be looking at the calculations. How do we apply these equations that we have derived? Otherwise, I'm Teacher Ivan from Wuna Educational Services. I kindly request you to subscribe first of all and hit the bell such that you get notified whenever we have a new video. Please, let us change the face of learning, whereby with the Wuna Educational Services, you can learn from anywhere at any time. That's the beautiful part of the digital learning. Please, we are here for free. Just do one favor: subscribe, share, comment, and like. Otherwise, we are Wuna Educational Services, your learning partner. We are here for your academic excellence. We have a lot of platforms. Go to our homepage, scroll down, you'll find those family platforms. Subscribe to them so that we make your learning easy and convenient. Otherwise, see you next time. Bye-bye.